So, hello guys, my name is Logavarman and my matrix number is 20 and this for the subject this system. This for the practical class 2. So for the let's without wasting any time, let's just straight get into the type sheet. So for the first one, the 0.1. So yeah, so and I'm from class DEM 3A. And this for the subject data system. So I forgot to put the class and lecture right there. So now I'm going to present you about the system that you touched to. So firstly, so these are the aim and outcomes. So first thing first, so just again explain the procedures. So for the first one, we will need to do the RS flip flop. So which is RS flip flop is obviously we will use the NOR gate for this one. So yeah, so for this one we need to use the live voice software to build this circuit. So without wasting time, let's just get into it. So first thing first, I'll be needing a battery, and I'll be needing a ground, and then I'll be needing a SPT switch, two of them, and then I'll be needing logic gate of NOR gate, two of the NOR gate, and then lastly I'll be needing LED, which will be at the, and I'll be needing two of them. So now let's just connect this components according to the circuit, right? Okay. Right here. So this is how the circuit looks like. So right now I'm just going to put the uh, voltage is equal to 5 volt. So yeah, and then I'm going to rename this switch. I'm going to put the switch R, and then this switch S. S. Yeah, so we got two RS switch, and then this one will be named as Q, and this one will be named as Q bar. So this one is Q, and this one is Q bar. So I've completed the circuit right now. Let me just minimize this one. I just need to put the view. table. So let me just play this one. So first thing first, thing. Let me just get into the table first. It's just up both at 0 right now. So both of them at 0 right now. So for which means 0, 0 will be uh, so for the first one, I will put the 0, 0. It's already over here. So let's see the logic, which is 1 and 0. So for the Q, it will be 1, and then for the Q bar, it will be 0. So for the condition for this, it will be hold. So before I proceed, let me just remind you guys something about the logic gate. So if the output for Q and Q bar is 0, 0, it will equals to invalid. And if the output is 1, 0, it is equal to hold. And if it equals to 0, 1, it will be this 0, 0 is invalid. So it will be 0, and for the S, it will be 1. So let's see. First, for the R, it will be 0, and the S will be 1. So let's see the logic gate. And it is also 1, 0, which is equals to that. So the next one is, and it is 0, 0. This one is 1, and this one will be 0 again. So let's see. So when it's 0, 0, the logic gate will be 1 and 0. So we're gonna put it as 1 and 0, and the condition will be as hold. So once again, we will put this one as 1, and then this one will be remain as 0. So let's see the logic gate. It is equals to 0, 1. So we put here 0 and then 1. So the condition will be reset. So the condition will be reset. And then next one is 0. I'm going to put 0 again. So since I put 0, the logic gate is 0 0. So over here there will be 0 0. So since I put the logic gate, the logic will be 0 1. So yeah, the logic gate will be 0 and 1. Yeah, so for the 0 0 part, the logic gate will be 0 0 and put over here 0 and 1. Hold. So for the 1 1 part, put it up and then we just put this up. So for the 1 1, the logic level will be 0 0. Output will be 0 0, which is the condition is actually invalid. So for the second last thing, for this logic gate, first one is 0, the second one is this as 1. So the logic gate is 1 0. And the condition will be as set. So lastly, 0 0 again. But the 0 0, the condition will be as hold, which is equals to 1 0. So 1 and then 0, the condition will be hold. So yeah, that is the for the first one, which is the X called as RS flip-flop circuit. So for the second one, make a modification on the previous circuit by connecting the circuit illustrated as figure 2.3. Connect another switch for the CLK input and complete the table 2.2. So right now, this is the circuit that I need to do for the second one. And this is the table that I need to put the output. So for the first one, firstly, let me just put this circuit in the circuit in the live wire. First one, put new, open gallery once again. I just take all the components that I need. So, switches, gates, and gates, and two NOR gate. So two and two NOR gate, and then we need it. Right now, I'm just going to connect this. I connect the circuit right here. So bring it down a little bit over here. So it's right here. and you finish for the gate. Now for the log gate. Gate. Yeah, so yeah, get the circuit according to the diagram over here. So let me just rename and put the values accordingly. So this one will be named as bar. PLK one will be named as yeah, oh, I forgot to connect this one. Then this will be named as Q. This will be named as Q bar. All right. So let's configure the circuit accordingly. So let's just straight get into the table and let's see. So for the first one, so as you see, I have connected all the circuit over here, and for the first one, all of them are at zero. So let's just put right here. Is the first one is actually zero, and then one, and then for the condition is actually no. But when I there is some changes, which is put with zero and one, and then hold. So for the next one, this actually happens when CLK is to 100, and then the 01 is hold. So for the next one, I'm gonna go with the CLK 0, and then the S is 1. So for that, the gate is 0 and 1, and then the condition is hold. And then for the next one, I'm going to go with the 101. So CLK is 1, and the R is 0 as usual, and S is 1. So the answer will be 1, 0, set. So for the next one, this and the R and S will be, and the S, so the answer will be also same, which is 1, 0, set. So when the R is 1 and the CLK is 1 and S 0, so the answer will be 0, 1, reset. And then the next one is CLK is 0, CLK is 0, the RS will be, so the answer will be 0, 1, reset 2. And then lastly, everything is 1, which makes them 0, 0, and invalid. JK flip flop. I need to consider diagram as usual over here. Over here. I can just use this one too. Let me use this one. So diagram. So I just need to get the IC. This. This one. Dual JK flip flop. And then I will just put it over here. So the next thing you need to do is just connect these things. And then this one. So yeah, let me just check once again. So connect all correctly. And yeah, that's all properly. So emission multi-level. And so let's see. So for the first one, let's go to the truth table first. So for the first one, CLK is 0, and then J will be need to be 1, and then K is 0. Let's see. So for table 1, the answer will be 1, 0. Condition is set. So for the CLK is the 1, 1, and then same also 1, 0, 1, 0, set. And then for the second one, 0, 0, 0, same also 1, 0, reset. So if 1 0, same also 1 0 reset. I'm sorry, this won't be reset. This both of them will be actually hold. Sorry for the wrong one. So the next one will be 0 0 1. The key will be 1, this one will be 0 0. So the answer will be 0 0 1. The answer will be reset. So 0 1, and the answer will be reset. So for the next one, 1 0 1. So 1 0 1. The answer will be 0 1 2, and then reset. The next one, 0 1 1. So this one 0, this one 1. So truth table will be 1 1 0. The answer will be toggle. T-O G. The next one, 1 1 1, will be everything on. So 1 0, no change. And lastly, 0 1 1, which will be 1, and 1, which will be toggle to. 0 1 1, so which will be toggle to. Okay, let me get the battery and ground. Take it out. Take it out. There are two components, LED, both of them. And I only need one SPT switch. Uh, so these are the components for now I need. So let me just connect it first. Uh, it is shown in the diagram 2.5 is the key bit. Okay. Now I need one generator. So just get the generator here. This is the generator. So the generator connects the plus and which is right here. We connect it to the ground. And then for the oscilloscope, and then for oscilloscope negative one, I'll just connect to that. So for the positive one, I will connect it to the first Q, then for another negative, I will also connect it right here, and for the positive, I will connect it into the right area. So this is the graph. Need to this into the graph. So this put it origin 6 and the minimum will be 0. Time will be 1. This the so we can see it better. Yeah. This is the graph. So let's see what's the start for graph right here. So let it run first. So this result for the T flip flop, the rectangular form. This one I'm going to do about the D flip flop. So let me just open this one. Supply spectrum as usual, ground as usual. I need to the switches, and then I'll do where is it? So this is it. Which is over here, the double JK flip flop, and then I'll be needing inverter, and then I'm using two LEDs. So let me just connect all the circuits. So this is the circuit for the D flip flop. So let me just change the voltage here. This is 25. So yeah, so let me just animation logic out. So let me just play this one first. So for the first one, so let me just get to the truth table for the table 2.4. So for the table 2.4, let's see. So when the CLK, for the CLK, which one? The first one is 0 and the D is 1. See, the CLK is 0 and the D is 1. So the truth table will be 0, 1, reset. The next one is 1, 1. If both of them is 1, it's same also. So 0, 1, reset. Next one is CLK is 0 and there is 1. So it changes to 1, 0, set. The next one, when it's backwards, so the same one too, which is set, 1, 0, and set. The next one is 0, 0. Both are 0, so it's 0, 1, reset. Next one is 1, 0. Press 1 and 0, 0, 1, reset 2, reset 2. So it's 0, 1, and also 0, 1, reset. And it's 1, 1, same also, it's 0, 1, reset. So that's all from the procedures that I need to do. Thank you very much. And thank you very much for watching the video. And again, my name is Logavarman, and my matrix number is 090 M20 to the 1. And this for the subject, due to system, and I focus them